Today we are going to talk about long division of polynomials. You can use this to divide any type of a polynomial, any type. The dividend and the divisor must be in standard form. With all of the degrees represented. So if there is an x squared term that is missing, we would put that in with a 0 in front, substitute that in. And long division with polynomials is very similar to long division with numbers. For example, if I were to divide 27 into 453. I look first to see how many times, I don't need the 3 because 27 is less than 45. How many times does 27 divide into 45 without going over? And that is 1 time. If you multiply 27 times 2, it's going to be 54, which is bigger than 45. So I have to stop at 1. So then I multiply. 1 times 27 is 27, and I put that right here, and I subtract. So 27 from 45 is going to be 18. And then I will bring down this 3, and then I have to look and see now how many times does 27 divide into 183. And the most times 27 will divide into 183 without going over 183 is 6 times. So again, I just repeat my steps. 6 times 27 is going to be 162. And again, I subtract. 2 from 3 is 1. 6 from 8 is 2. And that's my remainder. But we're big kids now. So how do we write this as an answer? So 27 went into 453 16 times with a remainder of 21. So we write that as 21 over the 27. So 16 and 21/27 would be the answer to that. And when we're dividing polynomials, it works pretty much the same way. So for our steps, you want to be sure everything is in, we already said this once, standard form. Well, my pen's not writing. With all degrees represented, again, I will show you an example of that. Write the problem as a typical long division, which is what I just did with the numbers. Then we're going to divide the first term of the divisor into the first term of the dividend. So how many times does the first term of the divisor go into the first term of the dividend? We don't pay attention to the rest of the polynomials. We will then multiply the answer by the divisor and place the number, whatever you get, under the dividend. Then, just like with the numbers, we subtract. And when we subtract, that's like multiplying by a -1. So we will change the signs. And I'll show you what that means. Then you bring down the next term, just like we did with our top example. We brought down the 3, and we repeat the steps. 3 to 6. You keep doing that until you're finished and you don't have any more, and then you will write any remaining terms in a quotient, which is the same thing as a fraction. All right, so let's look at an example. So we have if we have m squared minus 7m minus 11, and we are dividing that by m minus 8, okay? So this whole thing divided by this whole thing. So we write it as, oh, first of all, we have to check, is it in standard form? We have m to the second, m to the first, and m to the 0, so they're in descending order, and all the terms are there, 2, 1, 0, and then m minus 8 is in standard form as well. So I did not have to do anything to that before I can divide. And now I'm just going to write it as a typical division problem. And so as the instructions say, I'm going to look at the first terms only. So how many times does m divide into m squared? Or think about what times m gives me m squared. Well, m times m is m squared. So that is my first answer to that question. Now, in step 4, I'm going to multiply these answers or these numbers. So, and it's like distributive property. I'm going to multiply the m times all of this. So m times the m is m squared, and m times the minus 8 or negative 8 is negative 8m. And keep in mind, our goal is for this part, the first terms, to go away. So if they're not the same, then you didn't pick the correct thing to multiply by. Okay, so now we are ready to subtract. So what I meant by changing the signs, well, subtracting m squared is subtracting m squared, but subtracting a negative 8 means I'm going to change this to addition, okay? So what do I get when I subtract those? Well, m squared minus m squared is 0, goes away. Then I have negative 7m plus 8m, so I get a positive 8m. And then I need to bring down this minus 11 here. Now I'm going to repeat my steps. So what times 8m, or excuse me, what times m will give me 8m? Well, 8. 8 times m is 8m. So now I'll take this 8 and I'm going to distribute it. 8 times m is 8m, and 8 times negative 8 is negative 64. So I just distributed that through. Now I'm ready to subtract again. So subtracting this and then subtracting a negative again turns to the plus, and that is the trickiest part. If you don't change all your signs, you will do the wrong thing and get the wrong number. 8m minus 8m goes away again. Negative 11 plus 64 is going to be a positive 53. And that's it. I can't divide anymore. So what is the answer to this problem? Well, we have the m plus 8. So our answer is m plus 8. And then we have the 53. So the 53, oh, it's plus. It's a positive 53. So it's plus 53 divided by or over my divisor, m minus 8. So that is how I write the answer to that problem. Let's look at another one. So for this one, I have 50k cubed plus 10k squared minus 35k minus 7. And that is divided by 5k minus 4. So I have k to the third, k to the second, k to the first, and k to the 0 in standard form. And here, this is in standard form also. So I'm just going to write it. Okay, so I look first, 5k and 50k to the third. So 5 times what gives me 50? Well, 5 times 10 gives me 50. And k times what will give me a k to the third. So I have 3, I have 1 here, I need 2 more. So times k squared is going to give me the k to the third. So now I'm going to multiply the 10k squared times the whole binomial. 10 times 5 is 50. K squared times k is k to the third. Got the same thing. And then negative 4 times 10k squared is a negative 40k squared. Okay, so remember here is where I'm going to subtract, which means I'm going to change my signs. This goes away. Positive 10 plus 40 is going to be a 50k squared. And then I'm going to bring down my minus 35k so that I can now see what 5k times what goes into 50k squared. So 5k, or 5 times what gives me 50, that's a 10. And k times k gives me k squared. So again, I'm ready to multiply the 10k times my divisor. So 10 times 5 is 50. K times k is k squared. And then negative 4 times the 10k is a negative 40k. Okay, going to go back and subtract. So this is 0. Negative 35 plus 40 is a positive 5k. Bring down the minus 7. And now repeat the process a third time. So 5k times what gives me 5k? That would be 1. 1 times 5k is 5k. 1 times negative 4 is negative 4. Now I'm ready to subtract. So this is 0. Negative 7 plus 4 is a negative 3. I'm now finished. So how do I write my answer? So here is my whole number part. So 10k squared plus 10k plus 1. And then my remainder is a negative 3, so minus 3 over my divisor, which is 5k minus 4. So all of this will be my solution, my answer. One more example. 3x to the fourth plus 2x squared minus 8 divided by x plus 1. So again, I have to check, is it in standard form, and do I have all my terms? So if you notice, I jumped from x to the fourth to x squared. So what I'm missing is an x to the third term. That is what I was talking about in the initial steps, where we need to make sure all the terms are present. So we have to put a 0x to the third in there. And then we also, so it's x to the fourth, x to the third, x squared. We don't have an x to the first either, so we're going to have to plug in another x to the first there. Our divisor is fine the way it's written. So here's what we have. We have x plus 1, and we are dividing that into 3x to the fourth plus 0x to the third plus 2x squared.